Greetings, ninth graders. It is I, your fearless leader, Mr. Mortensen. I hope you are having a wonderful day, and I hope that you find this video to be very helpful. We are going to be doing quite a bit with inequalities, and so I'm going to cover a lot of the different materials that we plan to go over for the next coming week. So if you're catching this right around the start, don't worry. We haven't done all of this yet. Or if you're catching this more around, say, a quiz date or something coming up, then hopefully you find this to be very helpful. All right? But as of this point, as of me recording this video, we have not done everything that I'm about to cover. So keep that in mind, and let's go ahead and let's just start out with a couple of things. So let's practice with a quick review on some inequalities that we've been working with. Let's try an example of negative x plus 6, and we will say that this is greater than negative 9. Alright? Now remember, a lot of times with inequalities, even though it feels like half the time we're trying to say what it isn't or trying to give a bunch of different answers, we still treat it a lot like an equation. So we have our x term, and we have our plus 6, and then we have a negative 9 on the other side of our inequality sign. So we'll start off just like we would with any other equation, and we'll subtract 6 off of both sides. Okay? So negative 6 being added on to a positive 6, that's just going to add to 0. And that'll leave us with negative x greater than negative 15. Okay. Now remember, we can't claim that we have solved a problem if it's negative x. That's like saying negative 1 times x gives us some number that is greater than negative 15. So we have to be able to finish up here, and remember we're going to divide by negative 1. Sometimes this logic was used just saying, well, if you have this, then you're going to flip all the signs around. In this case, we just have to make sure that we're changing the sign for x. Alright, so x, and I'm going to write my positive 15 on the other side. Well, let's think about this now. We have divided by a negative number. So what that means to us means that our new sign is going to be augmented in the opposite direction. Now, instead of being aimed at the x, it's going to be going the other way. And let's actually review this a different way. Let's go ahead and try and solve it in a different fashion, and I'll show you why we have to be sure to change that sign. So let's rewrite it out again. We're going to go negative x plus 6. We'll have our greater than sign and negative 9. Okay. This time, instead of moving the x, instead of moving the 6, let's move the x to the other side. So we're going to start by adding x to both sides. Okay, so what that's going to give us is positive 6. The x and negative x will cancel. We'll keep our sign. Okay, there we are. Alright, and now, in order to get x by itself, we now have to add 9 to both sides. Alright. So we will add 9, and that's going to make our negative 9 and positive 9 add to 0. And so if we add 6 and 9 together, that gives us a positive 15 is greater than x. Which, okay, so let's see here. So we have our 15, we have our x, so we have sort of the same looking thing, but now, instead of saying x is less than 15, we have 15 is greater than x. So if we think about that statement for a moment, it's still saying that we're looking at all numbers that are going to be falling under 15. And so if we were to actually rewrite this with our variable term on the left, remember we'd still want to augment the mouth of our Pac-Man looking inequality sign here. We'd want to still have that aimed at the 15. So as we can see, we got to the same answer. But because of how we were able to do that without multiplying by a negative, we never had to actually switch the sign around. at least in any formal step. But notice that because of the way we solved it, we made sure that the sign still had to be augmented towards the 15. So that's why when we do those negative division steps, we always have to switch the sign around, so that we can always still kind of arrive at that same value. Another way of thinking about it, and just a quick review step here from something we talked about in class, let's think of two numbers. Let's take 4 and 2. All right, and let's make a sign that's going to tell us, is 4 bigger than 2 or is 2 bigger than 4? All right, we would choose 4 is greater than 2. Okay, well that's all nice and good. Now let's multiply both of these by -2. Okay, so we're going to multiply both sides by -2. Common step that we might do in arithmetic. -2 times 4, that gives us -8. And then -4. Okay, well 8's bigger than 4, right? So why would we change the sign? Keep in mind, we just changed our whole sign here. Is it better to be in debt for $4 or in debt to somebody for $8? Technically, the case of, well, we hypothetically have more money. Once we get paid, this is kind of a smaller debt. That's the one that we would find more ideal. -4, that's going to be bigger than -8 on our number line. So in this case, since we multiplied by a negative, we had to switch the sign. And that's going to be a major thing that's going to follow us through the rest of our inequalities. All right, let's practice out one more here. And let's go with x over 4 minus 3 greater than -2. Okay. All right. Now, I didn't mention to have you stop the video before. Hopefully you did that. If you didn't, that's okay, though. But let me have everybody go ahead, stop the video, try and work this one out by yourself, and then we'll work it out as a group. All right. I'm going to assume that you paused the video at some point, and let's go ahead and start it up. All right, so we will start by adding 3 to both sides. Add 3. Add 3. That gives me x over 4 greater than, and in this case we get a +1. Those terms will add to 0. Okay. Then x divided by 4. In order to get rid of that fraction, we're just going to multiply both sides by 4. Alright? So remember, in this case, we're multiplying by a positive number. Since we're multiplying by a +4, since that's what we're multiplying by, we will keep our sign still augmented in the same direction. And that'll give us x is greater than 4. Alright? Alrighty. So feeling good there. Let's take one that we're going to solve, and then we're also going to find the intervals here. And we'll make sure that we graph these, I guess is what I'm trying to say there. So let's take one more. 16 plus 3x greater than or equal to -2. Okay. So right now we've been just starting out where we're more interested in just being able to solve the inequalities. So let's start this one up. We're going to start... Before we start, hopefully everybody's paused the video. Make sure you do that. Alright, I'll assume you paused. Let's start it up, and we are going to start by subtracting 16 off of both sides. Alright, so if we have subtracted our 16, positive 16, subtract the 16, that's going to give us a 0. And then we'll be left with 3x greater than or equal to, and we have -2 and -16. If we add those two negative numbers together, get a -18. Okay, that leaves us with 3x is greater than or equal to -18. Alrighty, so now we divide by 3. Divide by 3. 3 divided by 3 is going to give us just 1x. And we're going to be left with a negative 6 on the other side. All right. Now let's see here. We divided by positive 3, but wait, we had a negative 18. Make sure everybody can see that. All right, so if we divided a negative number by a positive number, what happens to our sign? Remember, it's only if we are multiplying or dividing by a negative number. If there's a negative number on the other side, we don't mind. That's going to give us our final part of the solution there. All right, and that's how we use a little bit of arithmetic in solving our inequalities. Now let's go back and just review another concept that we've had here, and that is graphing an inequality. So we're going to graph it on a number line. And on most of the sheets that we've had so far, it's been provided. But occasionally, we may have to draw them out. So remember, we have ourselves a line, and it's going to go forever in both directions. Right? Let me kind of scooch my paper in a bit. There we go. And for the most part, we will put in just our point of interest, which for our first problem here, we had x is less than 15. That means we are going to focus on 15. All right. And since we don't have much else put in here, we'll go with 14 falls on the left-hand side of that because it's smaller. 16 is one of our bigger values there, so we'll put that there. And we're going to start by making a circle right where 15 is. Okay, so we made our circle. And one of our important steps is going to be deciding on whether or not we're going to shade that in. Right? So let's look at our sign here. Here it is saying that we are looking at all numbers that are just smaller than 15, but not necessarily 15 itself. Remember, if it has the little line under it, then that means that it can be equal to 15. But in this case, it can't. So what that means for us, we are going to leave our circle open. Or in essence, we're not going to shade it in. And then we're going to pick numbers that are smaller than our point of interest. So we're going to pick numbers like 14 and